Everyone, we are live with Simon Peyton Jones, who is one of the co-inventors of Haskell, or as Philip Wadler would say, co-discoverers of Haskell. Simon is one of the longest contributing developers of the Glasgow Haskell Compiler and a renowned educator. We are going to have an interview or a discussion or just a chat with Simon, who was kind enough to agree to talk to us outside the normal GHC meetings that he sometimes holds with our team members. Yeah, so I've said that you're a renowned educator. At least Haskell community knows your reputation. And as our community grows in recent times, can you maybe tell us a little bit about kind of how this happened and yeah, like what does it take to take a person who doesn't know anything about Haskell and for that person to become a member of Haskell community?
So that's a kind of it may come as a bit of a surprise to you to learn that I have never taught an introductory course on Haskell. I have taught, I was a lecturer at Glasgow University, and before that at University College London. But at Glasgow, the idea was you take your senior professors and you put them on first-year courses, because the first-year undergraduates are ones you really want to enthuse about computer science. And at that stage, we were teaching Ada as our first-year programming language. So I became very good at teaching Ada to first-year undergraduates. Then so I give lots of talks about more advanced aspects of Haskell, like at the Haskell Exchange and so forth, but I wouldn't say that I have a lot of tangible experience of teaching Haskell to beginners, curiously. But I have been very much involved in with the reform of computing education as a school subject in the UK. So in the UK, we've now we used to treat computing as a kind of technology subject, a kind of vocational instrumental subject that teaches children how to use information and communication technology. And now we regard it as a foundational subject that children should learn like they do maths or natural science, in a kind of early and foundational way. And that raises the question about, if you're going to teach computing as an early subject to primary school children, on what should you teach them, right? And how should you teach it? So at the moment, the answer is, in terms of programming languages, the answer is, well, Scratch is wildly dominant for an initial language, and then Python has become very strongly established in school teachers' minds as the one that you would move on to. I've often wondered, what would it mean to teach Haskell as a first language to children, to 11-year-olds, when they move on from Scratch and start to move towards a textual programming language? But in my role as chair of computing at school, I've sought not to, as it were, promote that, because that seems like that's an unproven claim, right? I'm very intrigued by that idea. There's a book by Richard Pawson. It's just come out about teaching Haskell at school. So I think that would be he is actively doing this. I think not at primary, but at secondary. But a more interesting place to start, I think, might be with Excel. Right. So Excel is a programming language that every child learns at school, and it is a functional programming language. And as I've often remarked, it's the world's most widely used functional programming language by far. One of the joys of working at Microsoft is I've been had the opportunity to try to encourage Microsoft to turn Excel into a more decent functional language. At the moment, it's a terribly weak one, but gradually it's becoming stronger. And this is a banner year. This is the year that Excel has got Lambda. For the first time, you can write fully first-class Lambda, as Church described it, in Excel. I think that's amazing. So you can do church numerals, and anything you can do in Haskell, you can do in Excel now. I mean, a little bit more clumsily perhaps, but it's there. That's amazing. So I hope that line of development will continue. So my mental apotheosis would be that when we I can retire when we are teaching children functional programming using Excel. So that'd be the three parts of my life coming together: education, functional programming, and Microsoft. That would be cool.
Yeah, and as we know that Excel is also a functional reactive system.
Yeah, that's right. And so I think but it's such a weak language at the moment. If we can make it a stronger functional programming language, I think that we really could teach computer science, through Excel. I think that would be quite exciting. And it's not that distant now.
Yeah, that's really interesting.
And then maybe the passage to Haskell would then seem like less of a jump, right? The wonderful thing about Excel is you don't have to apologize for not having side effects. You don't have to say, oh, I'm terribly sorry you can't assign to this global variable. It just wouldn't make sense. Nobody asks for that. The whole framework, the computational paradigm, makes you never, ever think about side effects. And so there's nothing to apologize for. It's great. And then you say, oh, now, but it's inconvenient to do these more ambitious things in Excel, but now you can move on to Haskell, which is also easy and fluid. Ah, yes, there you go.
I guess it would be a little bit interesting how to introduce types to people who are coming from Excel, or you think it won't be a big deal?
I don't think that's such a big deal. I mean, I think types, of course, are a huge deal. But I think after you spent a little bit of time debugging your type errors in Excel, I hope you might think, oh, at last.
Right, yeah.
So has there been any research into making Haskell usable as a macro language for Excel?
I think I do remember somebody trying to make Haskell as a sort of plug-in language. You could write a Haskell formula in an Excel cell. Might be an interesting thing to do, but I think I'm working very much from the other end to say, let's work from the end that our users are familiar for writing equals sum A1 to A10, and then equals maybe they can do equals sum of filter of A1 to A10 lambda, XX bigger than 10. So work within Excel's formula language, and then that starts to become clumsy, and maybe switch to Haskell. But then once you switch to Haskell, do you want to have Haskell in Excel? Maybe. Another interesting place to work would be the Wolfram language. So the Wolfram language is another mostly functional language that is extremely sort of underknown about, really, and they have quite a lot of foreign function interfaces. I'd love them to have a sort of Haskell connection there as well.
By the way, if our viewers have any questions, they can drop them in Twitch chat, and Vlad, who just asked a question about Haskell as a macro language for Excel, will pick them up and relay them here.
Yeah, and may I say, please do. It would be more fun for I think all of us if you, the audience, do actually types of questions, and we will get to them. In fact, probably first.
Right. Okay, let's go. Let's go to from school, from university to kind of workplaces and people who are aspiring to become Haskell programmers, and Haskell community as it grew tremendously, I think, over the past 6 years. So from your perspective, from perspective of a person who's doing a lot of work on compiler and who's done tremendous amount of work over time to make it possible for all of us to enjoy Haskell. Yeah. What would you say it like how's this ecosystem is organized on the kind of more advanced level, like from the standpoint of how does it happen that we have that Haskell that we know and love, kind of?
Are you asking a question sort of about the Haskell community and the Haskell sort of ecosystem more broadly?
Yeah. So from the perspective of a compiler contributor, basically, to begin with, right? And then let's talk about industrial side of things.
So I mean, I suppose my central focus, and certainly my sole initial focus, was on the language and its compiler. But for a programming language to succeed in being useful to anybody, it has to, the language and the compiler has to exist within a much larger ecosystem of tools and libraries. And initially, Haskell had none of that. So a huge step change was when Cabal and Hackage came along. Right, that was, until then, there were some libraries for Haskell, but there was no good packaging and distribution mechanism for them. So Cabal and Hackage made a huge step change in the Haskell ecosystem. It made it possible to take GHC and Haskell, the language, and use it for production applications. And that was, I guess, was that the early 2000s, something like that. And then there was a huge growth in libraries. But then, and then we've seen lots of other stuff going about profiling and debugging, and more recently IDEs for Haskell, and all of this in aggregate is much bigger than the compiler itself, and is not my central focus. But I'm thrilled that it's happening, and thrilled that it's happening rather better now than it has in the past. But we can discuss that a bit more when we know where you'd like to go with this.
Right. Yeah. So basically, I understand that there are committees, right, for the compiler, and Vlad, for example, and you, of course, are part of them. But are there, like, let's recap for the audience and for people who might not know how's ecosystem part of this is clicking together.
Right. Well, so remember that the Haskell community has grown organically over 30 years. Right. So Haskell was born in 1990. So it's grown slowly and by accretion. It hasn't didn't come into birth suddenly, large. It's just grown over 30 years. The second thing to remember is Haskell has had no corporate sponsor. It's not like C#, which was born, out of Microsoft and has a very active community, but it clearly had a hugely credible sponsor, and which immediately became very large. So Haskell has sort of grown slowly without a central sponsor, and that has meant that it's the community has grown in quite a distributed way. So the folk who are building Cabal and Hackage are rather different to the folk who are doing GHC itself, and they're rather different to the folk who are doing Stack, and rather different to the folk who are doing IDEs, and that's a strength, right? Diversity is good, and it meant that each sort of group of volunteers was had autonomy and a sense of agency about what they were doing. But of course, the more critical Haskell becomes to the more mission critical it becomes to the more organizations or people, that places more stress on this rather loosely coupled distributed kind of organization. So by way of an example, for the language itself, so for a long time, how would we get new features into the language? Well, it would basically be Simon Marlowe and me would think, well, we should so do this, and we just put it in, and there it was in GHC. And or an intern would come and spend a summer at Microsoft and would implement something. So, but as the language became more important to more people, it became we had to pay more and more attention to not being disruptive for people. So, and also it became less satisfactory to say the way you get something in the language is by knowing Simon, right? Partly because it's obviously too elitist, but also because it's just makes it too much of a bottleneck. So that led to the GHC proposals process, right? So now you can, it still, of course, has its faults, but at least it means that if you want to get something into the language, you can write a proposal and have it discussed by the community at large, and then have it agreed or not agreed by a committee. And so that's a way in which we've, incrementally moved towards something a bit more transparent, and I very much hope something that offers more of a voice to more people, so that Haskell is, the GHC developers, and certainly not by me, but by the community at large. It is a shared enterprise, and I think it's really important to give everybody a voice in that. We could move on to talk more about the foundation, but I'll sort of stop there for now.
Right. If there are any community-related questions in the chat, I don't think so. But yeah. All right. So Yeah, I might have a question about what you talked about right now, which is that in my view there's a trade-off, right, in terms of like kind of velocity of feature development that you can do if just two Simons come together. Yeah, they can be very quick and roll out maybe experimental features quickly, maybe into some branch or some custom release of GHC for people to play with and talk about, while having reasonable understanding that these features will eventually end up in upstream. Yeah. Whereas when there is the proposal system, which I absolutely agree is superior to Simon's getting together and figuring something out, but there is a big fear that the velocity and even the potential for a feature to end up in the compiler is greatly lowered. So what are your commentary on this? Maybe calm people, calm down people who think like this. Did we lose Simon?
In particular, what it means to be a programming language, and a language that is used in production that people are relying on. Are we still connected well, by the way? I'm getting various sort of network outage messages.
Yeah, I think that the problem might be on your side. I'll just confirm with Vlad and Denise.
Yeah, I think we've lost like 1 minute of recording.
Right. Yeah. So let's roll it back and let's roll back to the beginning of the question. And if we'll have disruptions in connection again, maybe turn off camera or something like that.
It sounds as if things are okay again now.
So yeah, the question was two Simons deciding what to put into compiler is fast. Proposal, and then, as far as I understand, that it has to be a complete consensus of community is slow. And it's scary for people who have some bright idea about the compiler, maybe. So how would you calm down that opinion or counter this opinion?
So let me take, there's two different things going on here. One is there's a tension between a language and a compiler that is a laboratory for exploring the bleeding edge of what it means to be a good programming language, and particularly what it means to be a good functional programming language, and particularly the bleeding edge of type system stuff in that area, right? And Haskell has always been a laboratory like that, right? It explores a particular corner of the design space for programming languages, namely purely functional programming languages, and really tries to invest in that. And that isn't that being a laboratory, right? A motherboard for to plug in lots of ideas is in tension with being a utterly reliable baseboard for mission critical applications in industry, right? That is a tension which other languages have, mostly, addressed by becoming by not changing very much, right? But erring on the side of the latter, becoming very, very solid and reliable, but not able to move very much. Haskell at the moment is still moving quite nimbly, right? Quite quickly, quite big changes. We had a lot of discussion about dependent Haskell. We have, linear types got in recently. So there's a lot going on, in Haskell at the moment. So now, so to a certain extent, we navigate that tension by a kind of consensus among Haskell's users that they're signing up to being part of a rather grand experiment, right? And the ones who really don't want that are probably not going to use Haskell. But at the same time, we now pay exhaustive attention to back compatibility questions and to migration plans and so forth. So we take all these issues much more seriously than we did. So, but nevertheless, I would be very sorry to lose that. Personally, I do not want Haskell to move to we're not going to change it anymore because it's too important for our mission. I want to keep moving, And if that's my personal thing. I don't really own Haskell anymore. Maybe everyone else will change, but that's my personal view. So then there's a second component, which is we agree that we keep moving, but how do we keep moving? How do we decide what to put in? The process of putting new stuff in the language. That's his proposals process. So first thing to say is, I think you're describing I think the process is often perceived as being more intimidating or difficult than it really is. It can be slow, and it can be slow for two reasons. Number one is a good reason, which is that there's a lot of debate, right? And proposals massively improve, in my opinion, through this debate. There are very significant changes happen to many proposals in the process. So I really like that. It takes time, and it may, if you just think, I've got a good idea, I want to do it, it's frustrating to spend 3 months talking about it with the community and seeing it improved, right? You may not even think it's improved, but somehow there's a greater consensus involved about it. But I think that's basically a good thing. The second thing is not such a good thing, which is that the committee can be slow, right? Why is that? So we advertise, that once you say as a proposal author, please, accept or reject or push back this proposal, submit it to the committee. Then stuff is supposed to happen within a month, right? And it doesn't always happen within a month. And why is that? Well, I'm at fault as much as anybody. Everybody's busy, and the committee is consisted entirely of volunteers who are giving their personal time to thinking in detail about language changes that other people out of the blue propose. So that's quite a big gift that they are giving to the community. And so, I want to apologize to everybody for whom that has seemed like a delay, and to say, if you think you could make that better, please volunteer. Next time we ask for nominations, nominate yourself. Right? We need people who are willing to devote the thoughtful cycles to doing it. But sometimes proposals, simple ones, they get proposed and agreed, in a few weeks. It isn't and should not be that intimidating. And I feel apologetic when it is. And if anybody's feeling bruised by this, come and talk about it specifically about the process and say, I'm finding this a bit difficult. What can we do?
Well, we've got a bit of positive feedback in the Twitch chat saying that the proposal process actually makes it less intimidating for a random person to bring in a new idea because there is a clear step-by-step guide on how to do it.
Mm-hmm.
And we've also got a question. If a new Haskell compiler were to be developed from scratch, are there areas of the compiler that would have a great opportunity to improve over existing compilers, given the knowledge the compiler community has accrued? I suppose it's relevant to Haskell because Haskell is often used for compilers.
Yes, I see. So you think, is the question, if you were rewriting GHC from scratch in any language, but let's say Haskell, would there be an opportunity to design it differently so that it would work better?
Well, I don't think that this person is focusing on GHC specifically, but what are the lessons of the Haskell compiler community that we have accumulated so that when we are writing a new compiler for any language, what are the techniques that we would use and what are the things that we would avoid? Because Haskell, it's got a reputation as a language for compilers, but aside from being a good language, there are probably best practices, and GHC developers probably have a good perspective on that. What works well in the GHC compiler and what could change?
Yeah. I find it hard to think of any in sort of implementation terms. How would I code it differently, if you like, if I was doing it again from scratch? I'm not sure. Sometimes I've a lot of the compiler is very monadic, so it actually has quite, in some ways, quite an imperative feel to it. There's definitely one step followed by another, and I feel as if it's maybe somehow over monadic, and yet that is a very convenient way of plumbing stuff around. So anything else about the overall structure about how to write the compiler? I'm not sure. There's a continually refactor the compiler, but I wouldn't say that there's some there isn't something which I think, oh, if I just had 6 months to refactor this large chunk of stuff, that I would do completely differently. Lots of incremental refactoring. I'm not sure I can give a very good answer to that question, Vlad.
Well, architecturally, do you think that GHC got it right with like its pipeline and the structure of its components?
Yeah, so I mean, I think, oh, let's see. So one opportunity that I think would be interesting to exploit more is whole program analysis, right? And there are a couple of people who are working on this. The sort of people who are working on a sort of grin-like backend. So GHC really is very much a separate compilation device, and doesn't really do any whole program analysis. And I think for a long time we've known that there's potential opportunities for quite large gains if you do a whole program analysis, but it's quite hard in engineering terms to deliver on those gains. So we've never seriously tried with GHC, but I think that would be an interesting thing to try. Another thing that I would love to make more of is super compilation. So with Max Bollenbroek, we worked quite hard on super compilation, which is a kind of like a super inliner, just inlines like crazy and does fuses things without using shortcut fusion. It's just an amazing technique, and if we could collapse all these layers of abstraction that we build, we build functions that call functions that call functions that call functions, and we build things and we take them apart, we build them until we take them. If we could collapse those layers of abstraction, we might be able to go a lot faster. But we could. Super compilation is very prone to getting enormous code blow up through lots of inlining without actually getting much performance improvement. So we never found a good way to, in engineering terms, of setting all the knobs to do it. Read the papers. There's a couple of papers on my homepage about super compilation. I feel as if that's in sort of big picture terms, that's still an unrealized dream.
Yes,
program analysis.
Thank you very much. And also to the person who asked the question, I would recommend Simon's talk about core, where it's discussed that the greatest architectural decision of GHC was to use a small internal language. So let's now get back to our scheduled
program. And that just to reinforce that, I think that's one bit about GHC that really does work well, is the this very small internal core language. And I'm quite proud of the fact that GHC's internal core language is statically typed, remorselessly statically typed right the way through to the back end. I'm not sure I really know any other compiler whose entire optimization pipeline is statically typed. Now, you may say, why bother? Because after all, a compiler bug, if there's a type error there, it's a compiler bug. Yes, but it's a very powerful check. It keeps us sane and honest a lot. Sorry, go back to your mainstream.
All right. By the way, does it happen a lot in while you're developing GHC? Like, do you catch the compiler bugs like this?
Oh yeah, all the time. So very often we say switch on core lint, and lint is this internal type checker that type checks the core program after every pass, and it's very common to have a lint error at some point. And the great thing is it catches it right. So you've got 20 passes, it catches it after pass 13. You know exactly where the error is, right? Imagine the difference between that and compiling right the way through to executable code and then getting a seg fault and try to trace it back to pass 13. It's astonishing. We take it for granted a bit, but it is really magic.
Yeah, we should somehow come back to community, even though I have a block of questions about PLT and etc. Okay, so we last touched on the subject of getting things into like kind of from community into GHC.
Yeah.
And you've mentioned about how as Haskell becomes more and more mission critical, there's more strain on community volunteers, not only to kind of do stuff that is related to the compiler, but arguably and dominantly stuff that is related to libraries and ecosystem.
Mm-hmm.
And what would you say is the most important proceeding of recent time that helps to alleviate the strain and to structure that commitment from the communities?
Well, so yes, as you say, dominantly the libraries, tools, and ecosystem. Yes, the compiler is a relatively small component of that. It's the component that I'm most focused on, but it is only a little part. So clearly, the biggest development of the last year has been the founding and launch of the Haskell Foundation. So previously the Haskell community had all these little volunteer groups, but nothing to really glue them together. So they all, were friendly towards each other, but it was easy for stuff to fall down between the cracks and just not happen. And also, with the best will in the world, volunteers tend to work on things that interest them. And to make an ecosystem of libraries and tools and stuff work together, there's stuff in the middle that's boring but useful. Like building good installers that work flawlessly across platforms. And it's hard for volunteers to motivate themselves to work, to spend their nights working on this. So the Haskell Foundation's mission is to, firstly, to drive the adoption of Haskell more broadly, by addressing some of these big underlying issues. One is sort of community glue, trying to provide a way to make everybody feel heard, valued, and participate and be part of the Haskell community, rather than being divided into these little islands, right, however friendly towards each other. And secondly, to help fill in the gap. This is sort of a technical agenda for the Haskell Foundation, to help fill in some of the boring but useful gaps, not to supplant or take over what volunteers are doing, but rather to sort of take over the bits they're not doing so that they can be free to be their most productive, right? And so we're trying not to supplant volunteers, but rather to empower them, if you like. So to do that, the Haskell Foundation, it's launched in November last year, or a little earlier. The Haskell Exchange. It now has a board. It has 2 full-time members of staff. That's Andrew Boardman and Emily Pillimore, who are the executive director and chief technology officer, respectively. They're actually making things happen. And it's very open. The board publishes its minutes. The meetings are very open. There's lots of subgroups, all of which are very open. So the idea is to provide a way for many people to participate and have a voice. So I hope that everybody listening to this, listening to this conversation, goes off to the Haskell Foundation and then starts to subscribe to the Haskell Foundation sort of discourse channel and listen to what's going on and participate in it, because it's all part of, we need to build a community of enthusiastic people who work together for a common goal. If we work all individually, we're less strong. So, and of course, the Haskell Foundation needs money, because that's the only way you can pay. If you want to do the boring but useful stuff, you have to pay somebody to do it, right? You can't expect that to happen with people's nights, and that means that companies who are making use of Haskell, which is, after all, given to them for free by that very community. Many of them are now saying, I would like to give back to the community by supporting the foundation to fill in some of these gaps. And so that's the sponsors of foundation. So that's really, very important our chicken and egg problem is to get that flywheel turning, to get enough sponsors to contribute so that Haskell Foundation can do something, so that other sponsors can can see that it's doing something valuable and we can contribute. Once that flywheel is going, I think we'll be in a good shape. But we're at that chicken and egg situation at the moment, and I'm wildly enthusiastic. I think the Haskell Foundation is the biggest and most exciting thing that's happened on the making Haskell real front for some time.
Yeah, and as you mentioned, they already have done some stuff, and for example, they are not afraid to question the defaults. Yeah, so as we know, the text will default or already defaults to UTF-8, which is, something that we in Sirocco made a workaround library for.
Yeah.
So. And now we don't need it.
Yeah, and previously nobody was sort of mandated to do that somehow, because it felt like too destabilizing and decisional. But the Haskell Foundation, because it has so many voices and because it has this umbrella status, has a mandate to say, this is a problem, let's do something about it.
Right. Yeah. And in general, for me, it's a very good signal, because one thing is to create new features, and the another thing is to make breaking changes and to question defaults. And if a community or an organization within the community has enough voice to question defaults and to make default changes happen, I think for industry it's a very strong signal that they actually are capable of a lot of stuff, even when it's like kind of not text string literals by default yet, but okay. So,
all right, we've got another question from the audience, and it's also about best practices. People are wondering when they're writing the libraries, which mechanism of code generation to prefer. So there are 3 different mechanisms for writing generic source code, which are template Haskell, GC generics, and generating source code as text and then feeding it into GHC. What is your personal preference when you are writing a library or some part of GHC? Which mechanism would you prefer to generate some boilerplate code?
Oh, so so it's interesting that metaprogramming, which is what we're speaking about, programs that generate programs, kind of, right, or has become, is becoming, well, it's always been important, but I think it's because sort of becoming increasingly important. And I think that's what gave birth to template Haskell in the first place. And it's been, template Haskell has been, some features in the template Haskell predates all this GHC proposal stuff. I don't know whether would it have made it. Yes, it would. But some of the things that have been implemented in GHC have, quietly never been used, and some have been widely used, and template Haskell is one of those. So to answer your question more directly, generating strings right into a file and compiling that has the advantage of extreme simplicity, but it just feels like the wrong thing to do, right? Who knows whether they'll type check, or that you get the strings right. It feels like that's what you do if nothing else will work. Even template Haskell then is split into 2 pieces. There's typed template Haskell, in which you can you generate terms that will type check. That would, if you can do that, that would be my preferred story, right? Because then there's no possibility that the generated program will fail to type check. No, it will not fail to parse, it will not fail to rename, it will not fail to type check. Those are good properties for a client of such a system, right? Sort of untyped template Haskell, which is the stuff that we implemented at first, is you need that when type template Haskell is not expressive enough, and there that it will parse and have the right scopes. You just don't know that it will type check, so that's a bit better. And I don't know the difference between template Haskell and generics. I think they're probably there's lots of stuff you can do in template Haskell that you can't possibly do with the generics library. And the generics library, getting good performance out of it, does rather relying on GHC's optimizer, which doesn't always do the job, right? So there's still a bit of a sort of unclosed loop there to give stronger guarantees for GHC's optimizer working on code generating the generic style code. Like, I'd like to be able to say, oh, look, I'm going to generate all these sums and products, but by the time you're done, none of them should live. Right, they should all have been fused away. You need to do enough inlining to make sure they've all gone. And we don't have a way to say that at the moment. That's the intent in the programmer's mind, I think. But I'd love to. That's another sort of open research question about how to do a good job of that. I don't think apart from saying avoid strings if you possibly can, and use type template Haskell over untyped if you can, I'm not sure I have any. I don't think I've got any template Haskell versus generic guidance to offer. I think it's other people would have more well-informed opinions than me.
Thank you for the answer. And personally, I would like to advise the viewer to read about the work of Andres Law on zero overhead abstractions in Haskell using staging, which actually combines typed template Haskell and generics to give useful guarantees. So that's an interesting area of research.
It's very cool. Yes.
Thank you. Yeah, I guess we can take this question, because I'm very glad that the questions that we have drafted internally are in line with what community is asking about, because we had already like a PLT question. Now we have a Haskell best practices question. So yeah, Simon, if we could kind of take it from here and kind of talk about Haskell best practices in a big picture, So like, as you said, Haskell, the language, Haskell, the ecosystem changed over time tremendously. Yeah. So what would you say that what are the additions to Haskell that changed the way you program, to change your programming style in Haskell the most?
So one thing to say is that while Haskell, the source language, has changed really quite a lot over time, Haskell, the core language, the internal language, the one that we were talking about, has changed very little over time. Right? It still contains let, lambda, variables, constants, functional applications, and the big change is to add casts and coercions, coercion abstractions. Now that was a single big change that we made, that added, like, the little internal language has had 7 constructors and now it has 8 or something like that. And it's really quite a small change. I mean, it has huge pervasive consequences, but so I want to say that somehow the changes to the surface language are superficial. I mean, they're profoundly influential in how you think about it, but they all compile to the same core language. So that means there is a certain intellectual coherence to everything that's going on. It's not just a rag bag of features that we keep slapping on, even though it may feel or look like that sometimes. To return to your question about what changes in the surface language have influenced my own programming practice most, well, it would the biggest stylistic change that's happened in GHC recently, I think, is the move towards this trees that grow idea. Now, trees that grow, you can search for that keyword. There's a paper on my homepage that about it, is a way to make sort of extensible data types using Haskell. And so our vision is to have a single. This is really useful for Haskell's abstract syntax tree. So Haskell has a very large concrete syntax, and so correspondingly it has a large abstract syntax, that is the internal data type that describes Haskell programs, that after you parse them, has dozens of data types and hundreds of constructors. And GHC then, during its renaming and type checking phase, decorates this tree with lots of additional stuff, types and scopes, and all sorts of extra stuff gets added onto the tree. So at first we had a tree that was just GHC specific, but then we realized increasingly that other people would like to parse Haskell themselves for other purposes. So what we really wanted was a sort of base library that contained the core abstract syntax tree with its dozens of data types and hundreds of constructors, and then some way for GHC to customize that tree to add all its decorations. And that's the trees that grow idea, and that lives off type families. Right, so we used type families, both type families and data families, quite extensively to power the trees that grow idea. So it's not what type families and data families were originally intended for. You can use them for all sorts of things, but it's a major application within GHC, and it's pushed a sort of stylistic change through the compiler. Any other changes, Vlad? You may have remembered. Are there any other sort of Haskell innovations that we use widely in GHC that come to mind?
I think GHC has to be somewhat conservative as to which features it uses, because there's the constraints of using an older version of the compiler for bootstrapping. And
yeah, but only two compilers ago, so we pull up the ladder pretty fast.
Yes, yeah, that's definitely a good thing. Although I must point out that there is a problem that we don't actually have a clean bootstrapping path from sources only for GHC. We rely on a binary seed.
Yes, you mean you need to start with a Haskell compiler to compile GHC?
Yeah, so you can't start with a C compiler and
that is true. Yeah, we're pulling the ladder up. Yes, you need to. If all the GHCs in the world got zapped, we would be in big trouble.
Yes. So in this regard, it's great that in the latest compiler versions, we've got compilation to be deterministic, because previously you wouldn't even know which binary you are getting when you're bootstrapping. Each time it would be a different binary.
Maybe I'll mention one other piece of programming practice, which is completely not to do with functional programming, but we use all over GHC, and I've never seen anywhere else, which is the using these notes. right? So it's so often when you comment code, if the comment is a subtle one, the comment grows and suddenly you can't see the code anymore because the comment is too long. So we just adopted this terribly simple practice of saying in the code, you say C note, and then you put square brackets, and then you put a title for the note, and elsewhere in that same module, typically, you will put the note with a, with a heading and an underline, and then some English language text. GHC has hundreds or thousands of these notes, and I read them and write them all the time. They are messages to my future self. And I read my own notes that I wrote 15 years ago, and I think, that's clever, because essentially I would have gone to that code. If it hadn't been for the note, I would have changed it wrongly. I've never seen this. This is such a simple idea. It's so widely used in GHC, and I've never seen anywhere else. So I just thought I'd mention it because it seems like, in any language I would now do this. It's a bit like literate programming. It's like a very low-tech literate programming.
Indeed, it is great. And when I was starting with GHC contribution, I read lots of notes in the source code, and they were of great help to me. So I wish more projects adopted this practice, which GHC pioneered.
Yeah, that's a good point, especially the point about that you can't see the code sometimes between big comments, especially when it comes to like here docs and inline tests. It's
that's right. And you want to say, and sometimes the note that you're referring to might be 50 lines long. And you don't want to be inhibited when you're writing it by thinking, this is occurring between, an if and a then.
Oh, yeah.
That's crazy. Right, you shouldn't be inhibited in that way. I want the note to explain the example and give the context and point to tickets and all of that. It's I think a little bit of IDE support would be good, right? So you can click on a note and go to its definition. But we've never done that.
It's up to Microsoft to figure that out, right?
No, there's a lot of people working on IDEs for Haskell these days.
Fair, yeah.
Yes, there's been a lot of improvement in the Haskell IDE experiences lately. So if you happen to be using Visual Studio Code, you just install the extension. And for small projects, such as projects which a Haskell beginner would develop, it works perfectly well, and I highly recommend it.
Yeah, I think this is a big change that's happened, because for years we all thought, we should have an IDE, but nobody was prepared to step up to building one. And then two things changed. One is that the community got bigger, and more people who were interested in IDEs got involved. And also, I think probably another change was the advent of things like Visual Studio Code that means there's a sort of shareable component that does lots of the sort of tiresome stuff about driving pixels on the screen, leaving the Haskell IDE folk to focus on the Haskell specific pieces.
All right, we have another question from the audience.
Mm-hmm.
And this is a hypothetical question. What if the community would have two versions of the compiler, a stable one and an experimental one, so that both would be convenient to use in projects? And if there was a toolkit for collecting statistics on the use of new features, and then it would be easier to decide which features are worth developing and maintaining.
I'm terribly unenthusiastic. I mean, I see the motivation, but it's really hard maintaining GHC. It's a mass. It's hundreds of thousands of lines of Haskell. Well, maybe 200,000 lines of Haskell, and it's extremely. I spent a lot of time staring at it. Now, the thought of maintaining two branches, right, and then trying to port some feature from one branch to another. These features are not, just single patches, right? They are, to make everything work, you do a patch and then you find something doesn't work. So a lot of other stuff is happening in between, and then you do another little patch on top. They're incrementally improved. There's a long incremental process to making everything work together. It would be, that the two would diverge and would never come together, I believe. So I just don't think it's feasible. I think what we should instead do, and what we try to do hard, is to feature gate everything. So everything's behind an extension flag. And if you don't switch the extension flag on, you should see the, as it were, what you call the basic compiler. And if you switch the extensions on, you see the advanced one. But we have one code base. I can't imagine, and I know that isn't perfect, because then maybe you want to use a library that has used a feature that you don't know about. But that would also apply in the to the questioner situation, right? It would not just be 2 compilers, it would also be 2 entire library ecosystems in which the library ecosystem for the basic compiler wasn't using any of the features of the new one. I can't imagine it happening at all. It doesn't seem feasible to me.
All right, that matches my opinion at least. And we have another question.
I think the within all of that, saying how can we keep our practices and how we develop GHC and our releases, how can we keep all of that so as to absolutely maximize the reliability of GHC for people who do not want sexy advanced features, right? That is a priority and should continue to be a priority, and people who want that should keep saying when they're being, if they find we're shooting them in the foot, perhaps accidentally, they shouldn't just grin and bear it. They should sing out and say, this is a problem for me.
Yes, GHC has a large regression test suite. So any new feature that is added is actually supposed not to break any of the existing features. And if it happens to you, please do report a bug. So GHC tries to be both a research vessel and an industrial compiler. So another question from the audience that we have is about popularity. And the person asking is assuming that the more people use the technology, the better the technology would be itself. So I suppose there is some truth to that because we get more feedbacks. And if there is a small number of vacancies, no one would learn the language. And if there are no people who know the language, companies would not use it for the project. And if the companies are not using the language, then people would not want to learn it. So how would one go about breaking this negative feedback loop and make a new language more popular? How Haskell did break out of being a niche research language?
Oh, that's an interesting question, because I think the question is right that the typical life cycle for a language is to go in either to be used by a modest number of people, a few tens, a few hundreds, a few thousands, and then gradually die out, or to very rapidly become used by a lot of people. So for the latter, you might think of Ruby or Python or Clojure or C# and so those rapidly become mainstream. So Haskell is extremely unusual in that it has done neither of those things. It has grown slowly and organically over 30 years. So we never, as it were, so C#, for example, broke out of the chicken and egg cycle because it had a big chicken, namely Microsoft. A language like Clojure didn't have a big chicken, but it was sort of picked up by a particular community and was very good for particular purposes. It's always when languages succeed rapidly, there's always some sort of socio-technical thing going on. And it's different for each one. So I'm not sure it's possible to generalize. But Haskell, I think, is unusual because it has grown slowly. It has neither slowly died out, nor has it grown explosively. And so why has that happened? What has made it special? I don't know. Perhaps it's that Haskell's distinctiveness as a purely functional programming language, it does inspire a certain dedication and commitment on behalf of its adherents, right? Once I feel as if once you've used Haskell, you really don't want to go back. Once you've used it and like it, you really don't want to go back. And so maybe as the community's grown, they've stayed with us, right? And I hope that this will continue to happen. That is, I mean, already at even at the stage of the life cycle we are, I think many companies, certainly bigger companies, would be cautious about adopting Haskell for a mission critical project because of their concern about whether Haskell would still be around in 10 years time, or whether they would be able to hire enough Haskell developers. That's why it's typically smaller companies that make a choice to adopt Haskell, because they're sort of less anxious about these issues of scale. And also, maybe they're also more worried about whether they themselves will be around in 10 years' time if they're a startup. But I think one of the things the Haskell Foundation also will do, I think, is increase the level of credibility that the language has, right? So it makes it you're more likely to believe that Haskell will still exist in 10 years' time, and that there will be there'll be good educational materials, that there'll be good tooling, and maybe that there'll be a good supply of Haskell programmers. You're more likely to believe that because of the existence of the Haskell Foundation once it becomes at least firmly established. And of course, as your questioner points out, once you establish that credibility, that then leads to more people thinking, oh, let's adopt Haskell or use it or learn Haskell and so forth, and that feeds back. So I hope that the Haskell Foundation will materially at least improve the velocity of our virtuous spiral. We're in a very slow virtual spiral at the moment, and I hope that the Haskell Foundation will sort of increase the gradient a bit. But in some ways, I hope not explosively. I think it is very difficult to manage explosive growth. I'm perfectly happy with organic growth, as it were.
Well, it seems that GHC achieved something really great by growing this way. And there are, for some reason, no competing compilers. Why are there no other Haskell compilers in wide use out there? And how hard would it be to write another one, let's say to the Haskell 98 standard, or to the Haskell 2010 standard, or to the latest pseudo standard Haskell 2021? Yeah, so what would it take to write a new Haskell compiler from scratch? Because Haskell is not a Lisp, right? It got to be difficult.
So, number one is, I would welcome that, right? So I remember right back when we started GHC, we were in a very friendly competition with Leonard Augustin's compiler for Haskell called HBC. And, whenever we produce a release or whether he produced a release, we'd rapidly benchmark against each other and see what they did and what features they had. And we were in a kind of friendly arms race with each other. It was great. And then there have been other Haskell compilers written from scratch with typically around a Haskell 98 like standard like NHC and the Helium compiler out of Utrecht, and indeed Hugs. But it's hard to sustain. It is hard to sustain something of the scale of a compiler for Haskell. It's a big language, and even anything that does even Haskell 98, let alone Haskell 2021. Is a big engineering project. And then you've got to think, how do I sustain that? So how does GHC sustain that? Well, it sustains that by this large pool of volunteers, right, who make bug reports, who characterize bugs, who report them, and who then and then help fix them often. And that pool of volunteers in turn is driven by the feeling that they're part of a community enterprise. There's a network effect, right? That means that once you become successful in a field, people tend to congregate around it, and that makes it more successful. So I think, sadly, in some ways, it is difficult to compete. I think that's a pity, because I think diversity is good, but it's hard to compete with something that's gotten to the scale of GHC and a community of the size of GHC. So then I think if we're going to be stuck with a kind of de facto standard, as GHC in effect is, then we must just concentrate on making it as participatory, as open, as shared ownership, as easy to get into and contribute to as possible. And we're trying hard to do all of those things, but then that diffuses to a certain extent the disadvantages of being a de facto standard if it's something that everybody can feel a sense of ownership of.
Right. I, for one, would welcome a new Haskell compiler, because if it was written in C, then we would solve the bootstrapping issue I mentioned earlier.
Oh, not at all. Right? If all the C compilers were nuked in the world, we'd be stuck in a different problem, right? It's just another, if all the binary C compilers went, we'd be stuck.
Well, for C compilers, there is an effort to bootstrap them from assembly, so we would get to a bottom sooner or later. It's not turtles all the way down.
Anyway, but I think
we've got another question,
yeah.
And this time it's an organizational one. So there are often many libraries to do the same thing. And do you believe that there should be an effort, for example, from the Haskell Foundation, to select some set of libraries as the standard for a particular domain or a set of tasks?
I don't know. I think that's a question I'm not a good person to answer. Right. So I can see the pluses for that is it makes it easier for people walking up to Haskell to say, how should I build my web framework? Right. They say, well, you just use this one. The downside, of course, is that there aren't really any silver bullets. Nothing is perfect, and so there may be several web framework, libraries or packages that are, have different strengths and weaknesses. And then should the foundation be in the business of picking winners? I don't know. And I think this is maybe this is a conversation to have, through the foundation channel. And maybe it should be not just this is the right thing to do, but here is a beginner's toolkit, a sort of base collection of libraries. I don't know.
So how would you recommend a person, just some member of the Haskell community, who's got this idea, to communicate it to the Haskell Foundation? What would be the communication channel to ask that question?
There's a discourse. We're using discourse for the Haskell Foundation. Just start writing on that.
So any person can join, right?
Yeah, any person can join. Yes, and indeed, yes, absolutely. There's multiple channels, so it's very open setup. So of course, like any big community of lots of motivated and passionate people, you can't guarantee to get everyone's attention. Right? There's nobody whose job it is to pay attention to you, as it were. So, there will be ideas, perhaps even good ideas, that don't get the attention they deserve. But that's the challenge of working together as a community, that we have to all look at each other's ideas. Yeah, that's good. Maybe we should big that up. I'm just trying to encourage everybody not to think, oh, I'll just suggest this at the Haskell Foundation, they'll do all the work. What is the Haskell Foundation? It's only 2 full-timers and 1 million volunteers. We have to, it's our foundation, not their foundation, right? The Haskell Foundation is us, all of us.
Yeah, that's a great perspective. I'd also like to add my humble opinion about the question, which is I agree with Simon completely. Is that no one should pick the winners. Something can be only maths should pick winners. Yeah, if something is foundationally correct, then probably it's the winner. Yeah, but as far as industrial libraries go, I think that there is a set of libraries already that are de facto winners, and yet we sometimes have this. I don't want to sound pessimistic or negative, but there is this kind of bloat of libraries sometimes when we already have, for example, some library that already encodes stuff into JSON. Yeah, perhaps we should work on it being applicable to industry, applicable for beginners.
Yeah,
have reasonable defaults, etc., etc. I have some pet peeves.
Right. So you mean essentially Word is a bit like GHC itself, where a de facto library has emerged somehow as the winner, then we should all pile in and make that better.
Yeah.
Rather than be very neutral, right? And maybe that's true, and that perhaps again that is a conversation that the foundation could have.
Yeah. Actually, I will contribute to the person who asked to the thread on Haskell Foundation's discourse of the person who asked with my input as well.
This also intersects with the business of the Core Libraries Committee. So the Core Libraries Committee is concerned with some particular libraries that we perceived, this is now many years ago, as being so core to any release of GHC that we should make, with the Core Library Committee had a particular collection of libraries under its purview. And it's affiliated to the Haskell Foundation, is still very active. So be a conversation to have with them too. A bit hazy about whether it would be only their business, but that's another reason for having the foundation. If it's not only their business, we got a place to go for a broader conversation. But we shouldn't leave them out, right? They're the most obviously well-informed party to this.
Right. So yeah, let's talk a little bit about stuff that is that beginners and intermediate Haskell developers who are just coming into the industry. Perhaps it's their first Haskell paid job, maybe. So what they experience. Yeah. So let's talk about very distinctive feature of Haskell, which is it being lazy by default. So if you are to explain to beginners and people who are just starting out with Haskell, writing let's say industrial Haskell maybe, what would you tell them about laziness? Like, why is it important? Why are there so few lazy languages? Yeah.
So I tell them, read John Hughes's paper, Why Functional Programming Matters, which is a extremely articulate exposition of why laziness, how laziness enables you to build more modular programs. That said, JT's internals have a lot of stuff that's about inferring strictness through strictness analysis, and also Haskell has many annotations, bang patterns and seek and so forth, that let you force the compiler to use call by value. So the intermediate language, in fact, although it is a lazy language, it has a lot of support for call by value mechanisms as well. So in effect, it's not lazy evaluation. It's not really an either or. Every lazy language, well, certainly Haskell, has a lot of support for strictness. And strict languages, strict functional languages like ML or CAML, typically have support for laziness as well. So then it's just a question of where you start, and we kind of move towards the middle. Now, ideally, I suppose you'd like some glorious unity in which it was somehow you didn't have to have a default, but I don't know how to do that at the moment. So Haskell at the moment has the default of laziness. Now, people often say, well, if you were designing Haskell again, would you make it strict? So I think to begin with, historically, the defining feature of Haskell was that it was pure and lazy. And in a way, it was remorselessly pure because it was lazy, right? Because with lazy evaluation, you don't quite know when anything is going to be evaluated. And so if it's impure and you have side effects, opening valves or writing two variables, you don't quite know when those things are going to happen. And if you're opening valves, you really want to know which valve you're going to open first. So a lazy language that is impure seems infeasible. So Haskell's laziness made it impossible for us to contemplate impurity. Now, of course, we still let it in through the back door through unsafe perform IO, but it's called unsafe perform IO for a good reason. We even put it in the name. Now, so the most helpful thing about laziness in retrospect was that it forced us to be pure, and that meant that Haskell initially couldn't even do input-output because input-output is impure. And that in due course led us through Phil Wadler's brilliant insight of taking ideas that Eugenia Moggi had been writing about monads and applying them in a very practical context of a programming language. And that led us to our paper, Imperative Functional Programming, which was the sort of breakthrough moment at which we said, now we can see how to do both pure and impure functional programming together in the same program without the impurity messing up the purity. That was an amazing, amazing moment. And it would not have happened had we not been forced into this pure vision by laziness. But now it has happened, right? Now the question is, now we know how important purity is, right? Could you imagine a pure, strict language in which you do not give in to impurity, even though you know the evaluation order? And I have flirted with the idea that you could redesign language as being a strict language, and I think then 10 years later, people will be saying, wouldn't you, if you were redesigning Haskell 2, would you make it lazy? Right?
Yeah.
The grass is always greener on the other side of the fence. So I'm content with our choice, right? It's not the only possible choice. That I'm very strongly believe that purity is something we should stick to remorselessly. I'm not, but I'm very open to the possibility of having a pure, strict language with really good support for laziness. I think that would be, but I don't want to shift Haskell to that because it would be too big and disruptive a change for too little a payoff.
Right. Well, you say. You still emphasize support for laziness, right? Which makes me think that you are using laziness in practice, right?
Yeah.
So if you would tell again beginner, intermediate programmers in Haskell how what are your patterns? What are your approaches to using laziness?
Yes. So all the time, I think I probably am using laziness in little ways all the time. So I have, I write a function definition and a where clause, and in the where clause, I've got lots of definitions, and some of them will only be evaluated some of the time. In some branches of, this is a definition with many clauses, many guards and conditionals. So it's got many control flow paths, and only on some of those paths will these things be evaluated. But I don't worry about that. I just write down what their values are, and I know that they'll be evaluated if and only if necessary. One design pattern that we use quite crucially in GHC that is to build recursive data structures. So in our internal data structure, the data structure that represents a type, say, mentions type constructors, and the data constructor that represents a type constructor mentions its data constructors, and the data structure that represents a data constructor mentions its types. And now we go round. So in fact, we've got all these data structures are circular. They all refer to each other. How do you build these loops? Well, to build the loops, you need laziness or some support for laziness. So the loops are very convenient. It means you're not continually looking up in symbol tables.
Well, alternatively, you could use mutation in another language. So
that's true. Yes, but now you have side effects, right?
Right. So laziness makes a great pair with purity.
Exactly so. Yes. And indeed, Don Syme actually has a very interesting paper about building circular data structures in F#, because his context was building circular data structures associated with graphical user interfaces, in which lots of things refer to each other, and he wants to build objects that refer to other objects that refer to the first one. I forget what the title is. He has a very interesting paper about how to do that, and laziness provides a very simple way to do all that. Of course, it has its problems, right? If you're accidentally too strict, then you just get a black hole instead of the circular data structure. That's really annoying and hard to debug. So it's not easy. Last thing to say about laziness, by the way, is that a problem of laziness is it does make it harder to reason about space and time behavior. Sometimes it makes programs more efficient, right, because they evaluate less, but the reasoning is a bit harder. So profiling is very important, and in space and trying to chase down space leaks is something that Haskell programmers probably spend more time doing than, say, Java programmers. Not that Java programmers are free of it; they have space leaks too, right? But I think Haskell programmers probably have more of them. So that's a cost that we have not, I would say, nailed. Better tools.
For me, as someone who also organizes work on Haskell projects, it's a very, in a weird way, it's a good thing, because I know that all of people who work on the projects that I organize actually know how to profile their code, which is not very common occasion in industrial programming, actually.
Yeah, and our profiling tools are getting better. There's quite a few of them now.
And laziness is also, as I've heard, very difficult to implement, because GC has the strictness analysis, and then it has a stellar RTS to execute lazy programs. And other languages, if they wanted to add laziness, that would be quite an engineering challenge.
Yes, or else would be, implemented simply but not terribly efficiently, and that, that might be okay if they're making very selective use of laziness. But it makes it it's a bit harder if you're using it pervasively and frequently. Of course, because they don't have laziness, they tend to have things like the iterator pattern or visitors or things, so that that you tend to get other programming patterns that arise as a replacement for laziness.
Yeah. All right. So I think let's have kind of. Let's wrap it up a little bit with my questions, and hope that there will be more questions from the chat. So something that is very something I spent a lot of time thinking about is the general state of modern day computing. Yeah. What are the computer programs or systems that exist currently that impress you the most, and why, if there are any?
I know that's almost too open-ended a question to give it much of a meaningful answer to. So I don't know.
I mean, we can go from the other end. Like where I'm going to with this question is that we have right now kind of this discord between the vast majority of programs are getting browserified and apified or whatever, yeah, and most of the time the industry spends is to cater to basically like two platforms for mobile phones, yeah, and to the browsers.
Mm-hmm.
Yeah, and kind of how do you personally feel about this reality that we live in right now, and how does Haskell fit into this picture? So this is kind
I suppose, I'm a computer scientist and a compiler implementer. These are mere execution engines as far as I'm concerned. So of course they dominate the lives of the people who are developing for them, but they're, I suppose, you write your Haskell and you have a compiler that spits out JavaScript or perhaps WebAssembly, and that runs in your browser or on your phone. So, I suppose the fact that phones and browsers have become so much more capable and powerful. I mean, in the olden days, they just wouldn't have been capable of executing Haskell, but Haskell is, relatively resource hungry, certainly compared to a language like C, I suppose. So, so I suppose does it really impose a big effect on the language? I just think of it as a different code generation. Maybe I shouldn't. Maybe it's more fundamental than that.
Well, from my observations, like of the industrial realities, as you know, from, for example, from our system engineering practices, yeah, they have this notion of technology readiness level, yeah. So, and in principle, fundamentally, it's not a big deal, as you say. And as far as I understand, your answer is that eventually we will get there.
That's right. But in engineering, you mean in engineering terms, are we ready?
Yeah.
Because I mean, you would know better than me actually, but I think probably that the quality of the tooling for a completely smooth experience of writing Haskell and having it run in your browser is probably weak at the moment, certainly compared to the competition. Yeah. Right. But that's something that I hope that maybe some people listening to this webinar may be able to help fix.
Right.
I mean, I don't see any fundamental reason why that should be difficult. It's just work. And I understand quite a lot of work and quite a lot of work by quite smart people. But are there any fundamental obstacles?
Yeah, I don't think there are. And gladly, again, in my opinion, there are a lot of libraries already that exist that we can learn from to basically create these stacks for Haskell that target these platforms.
So, for example, if I was to develop an alternative to GitLab in Haskell, is there anything in the ecosystem or in the language that is missing, or is it that I just need to put in the effort and the language is ready and the ecosystem is ready?
Oh, Vlad, I have no idea. Right, so because I'm, remember my, my perspective. I'm sitting in a, research lab writing a compiler. I have no idea, really, not a visceral idea of what it takes to write something like GitLab, or what tooling you would need, or how hard or easy it would be to do in Haskell. You need to interview somebody else.
All right.
Okay. And what do you think about the future of computing? Like, for example, do you think that we will have big breakthroughs in the way that computers run our code? For example, there's some research in States on and other places on reversible computing and making and quantum computing and stuff like this. Like if you could talk about this.
So I at one stage, when in fact in the 1980s, when I was at Cambridge doing the computer science diploma, there was a lot of excitement around the idea of designing hardware to execute functional programs directly. Indeed, there was a whole conference called Functional Programming and Computer Architecture, FPCA. Some of my first papers were at FPCA. It later merged with the Lisbon Functional Programming Conference. They were both every 2 years. So they merged to become ICFP, the International Conference on Functional Programming. But it was very interesting. It was functional programming and computer architecture. It's right there in the title. Isn't that an amazing thought? But over time, I think it became clear that the first, it's really hard to compete with Intel, right? It takes such an enormous investment to build hardware chips that it's very hard to compete. But also that when you have a really good compiler, it's not clear that what you don't want to do is to build hardware that interprets at runtime stuff that you could have compiled away statically beforehand, right? That would be silly. That's just investing cycles at runtime to do stuff that you can just, and that's really what GHC is spending a lot of its time doing. And it took us quite a long time to figure all that out. Wrote a whole book about that. So I can see some things where we could do with a bit of extra hardware support, particularly, better support for read barriers and write barriers for garbage collectors, not avoiding fetching cache lines for the heap cells that to be empty. I think there's some modest hardware support that could help. I don't know whether it would be transformational. I'm not at all optimistic. Well, quantum computing may change the world, but I don't think it'll do so quickly. It's always 10 or 15 years off, and I don't think it'll become. I don't think you're going to write word processors with quantum computing. I think quantum computing is likely to, even when I think it probably will start to become of direct utility, but I think it'll probably be in fairly specialized applications. I don't really know, but it's a bit about nuclear fusion. I think it may always be a bit on the horizon, but because it would be transformational, I think it's worth investing in. I'm just not holding my breath. I don't know much about reversible computing, so I suppose I'm saying from a hardware point of view, I think it's unlikely that a lot will change for most of us anytime soon. From a hardware point of view, I think probably the biggest thing that is changing for us computing wise at the moment is the whole machine learning, artificial intelligence thing. Now, I know it's terribly flavor of the month and terribly laden with hype, but the fact is that for years and years, for my entire professional life until relatively recently, I thought of, the way you get a computer to do what you want it to do is to tell it step by step, or perhaps declaratively, like in Haskell, exactly what to do. Now, machine learning is a complete end run around that whole thing. But if somebody said, tell me step by step, write a Haskell program to recognize a cat, that would be really hard to do directly in the way that we think about, writing algorithmic programs. But machine learning programs are quite good at doing that. Well, the program is pretty simple, and it has this, it's only a few dozens or hundreds of lines of code. There still is a program, of course, still executing on the same old hardware, maybe with a bit of specialized hardware support. But it, as an approach to telling a computer what you wanted to do, it's utterly different. Right. So it's as functional programming is different, very different from imperative programming. But if you zoom out a bit, then machine learning is way, way different again. And I think that's going to shake loose lots of stuff, and we need to think carefully about that. I do think that Haskell can be a really good language for describing machine learning kind of models, and I think there's a tremendous amount of experimentation in the machine learning area, so having a language which is easy to move around and explore and change things would be really good. There's some Haskell libraries around that, but I think in terms of the big influences on the future of computing, I think it's the leave aside the hype. I do think the whole machine learning thing is going to have a slow seismic impact. It's not going away. It'll have a long-term impact.
Right.
I don't think it'll directly affect functional programming, but it'll directly affect computers. It'll directly affect computer science in a big way. But I continue to think, thinking also about the future, that functional programming is on this long march to say, if you want to write a program in an algorithmic way, right, plan A, as it were, then I think that over time, functional programming will increase its, steady growth and infect the mainstream world more and more, right? I often say that when the limestone of imperative programming is worn away, the granite of functional programming will be revealed underneath. I still think that. So I think there's a long-term trend there as well.
All right, we've got a couple more questions from the audience. One is, what can a new contributor to GHC expect in terms of what work needs to be done? I'm assuming the person doesn't mean the GHC tickets, maybe the general direction of what is being developed. There is like effort on dependent Haskell and linear types. What else is there?
I mean, what other general lines of development are happening in GHC at the moment?
Yes, so if a new contributor decided to put in some effort and do their part, what general efforts could they join?
Oh,
yeah, and
well,
also maybe some.
Okay, ahead.
Sorry. Yeah, and also maybe some introduction, like intro stuff, like that anyone can pick up.
Yes, so I think anybody who wants to start to contribute to GHC, and I'd love people to do that. There is so much to do. We have thousands of open tickets, right? And the a way in is usually the way to, again, it's an approach that generally doesn't work is to say, I've got this big new feature that I'd like to implement, and I'm going to start to do it. Because GHC is a big complicated artifact. It's difficult to get to grips with. And also, to get anything actually into the compiler, you need to, well, if it's user-facing, you need to write a proposal, but even if it's an implementation thing, you need to get enough attention from the gatekeepers that say, are we going to allow this code into GHC? So you need to sort of earn their attention, right? It's a collaborative ecosystem, and a good way to do that is to start working on smaller scale things. And there are lots of smaller scale things that need doing. One effort that's going at the moment, for example, that's easy to join in and help with is a sort of reform of the error message infrastructure. So up to now, GHC has largely produced error messages by conjuring up strings. Well, not quite strings, but sdocs that explain the message. And that's not so good for IDEs, since they're sometimes reduced to parsing these strings again. That's terrible, right? So we should produce error messages in the form of a big data type, or several big data types that describe the error message, and then IDEs can have a much better chance of making sense of them. So there's a big process that is underway at the moment, big in the sense that it covers a lot of the compiler and will take quite a lot of effort to re-engineer the error message infrastructure to produce more structured error messages. And that's now at the stage where the groundwork has been done, and we just need to say, oh, for this part of the compiler, we need to turn this collection of 50 sdoc kind of messages into a data type. And that's something to which we can do that incrementally. That's something to which anybody could contribute, I think. What else? There's so many little things, and I don't know. You're probably almost better positioned than I am to respond to this question, Vlad, as you have become a major contributor, but you found a way in some years ago.
Yes. In part thanks to our calls where you helped me get into the hardest part of the type checker. I'm not sure I would figure out things like zonking by myself.
Yes, so trying to get into the bowels of the type checker, that's a pretty tough one. So I'd sort of recommend trying to do other things first for the other people listening.
Yeah, personally, I started with the parser because I had previous experience writing parsers, and it was the way in for me. So if you've got previous compiler development experience, try to apply your existing knowledge to what GHC does. It doesn't do anything completely exotic. Like you will find the usual architecture where it first parses the program, then it does name resolution, then it type checks it, then it desugars to an internal language, all the things that you expect, and books on compiler development are applicable, normal books. We've got a question, what is zonking? Well, I'm not sure we want to talk about it more than it's part of the compiler pipeline. And we've got an organizational question about the risk associated with big companies influencing Haskell. So the person is asking if there is a risk of centralization of the Haskell language development around companies with big capital and influence, like IOHK, Embargo, and Cardano Foundation. I recognize one of these three, but apparently they're...
That's oddly specific. Sorry.
So yeah. I guess maybe the questioner is thinking, well, if we have the Haskell Foundation, and if it is funded by sponsors, is there a risk that those sponsors might gain a sort of undue influence over the language and its direction? Would that be one way to decode the question?
I suppose so, yes.
Because so at the moment, I think there's very low risk of that right now, very low risk. So so for a start, the Haskell Foundation doesn't all it controls, right? All it controls is its own budget, right? That is the budget that it can use to employ people or to fill in gaps. It doesn't control Haskell the language at all. At the moment, the GHC steering committee is the gatekeeper for that. And so so a sponsor at the moment, I mean, our sponsors are fantastic. They don't get a seat on the board of the Haskell Foundation, and even if they did, they couldn't determine what Haskell was. They could determine the priorities of the foundation. So they certainly don't get a seat on the GHC steering committee, though I would love for some of them to, nominate people to the steering committee when we seek nominations, and we'd evaluate those in the usual way. So, and also, I don't think that our sponsors seek undue influence, right? They are seeking solutions to particular pain points they have, so that. And when they have particular pain points, they will often say, we'd really like to solve this problem, so we're doing GHCI on a Haskell program that has 11,000 modules and it's slow to load, right? Or when I modify my one module, even though it's not recompiling the other 11,000, it's doing something to them that's taking a long time, right? And that is a pain for us. But then when they do that, they typically say, oh, and we're prepared to pay someone to help solve this particular problem, and that's fine, right? That helps everybody. So I think it's a problem of it's a conceivable problem, but I don't think it's anything like a proximate nearby problem. And moreover, the foundation's board is fiercely independent. And has we've got we've been writing down very clearly how new board members are nominated and the process and so forth, and everything's governed very openly, and the board takes binding decisions. So it would be, I think, extremely difficult, even if they wanted to, it would be extremely difficult for a sponsor to somehow wrest control. And I don't think they even want to. So in short, TLDR, I don't think this is something you need to lie awake at night worrying about.
Yeah, and also for foundation, there is, as far as I understand, one limit of one representative of organization in the board.
On the board, yeah.
Yeah. This is what actually during our chat with Haskell Foundation, we also were asking this question, just as a thought experiment. Yes, because of course, as it stands right now, we don't have this problem, but we might have this problem.
Yeah, that's right. So we try to set things up so that there's a low risk of it taking place in the future. It's best to defuse things before they happen. But it's worth also saying how much we value and love the sponsors of the foundation, right? They are companies who are using Haskell for real in production. They're a source of ideas, of creativity, and resources to make the foundation happen. So we owe it to them to pay attention to them, right? It's not, we don't want to just say, well, throw the money over the wall to us and then we'll ignore you. That would be silly too, right? Unless we do things that they value, they won't sponsor us, and shouldn't, right?
Definitely. And also, I don't see a failure mode here. In fact, I'm happy to see that a lot of companies are contributing to the development of GC, not only by directly sponsoring any foundation, but also by sponsoring their developers to contribute to the open source compilers. So there is Twig, who are implementing linear types. I've seen a lot of contributions from Obsidian Systems, and I'm very happy to have an opportunity to work at GHC here at Sirocco.
Yeah, you've contributed a lot, and Sirocco or your customers have paid for that. So yeah.
Also, I want to humbly point out that Vlad is working on GHC full time.
Yes, and I think that's amazing. That's a huge in-kind contribution. This isn't just any old body. This is Vlad.
Yeah, I'm very happy that I have this opportunity, and I hope it lasts. I hope to continue contributing to GHC, and I will be also happy to see more companies support their developers who also want to contribute.
Yeah. Oh. I guess if there are no more questions from the chat, we can wrap it up with one question from Sirocco employees. We have the following question. Do Haskell engineers need to have a deeper background in mathematics? And if not, is there anything where it might be helpful to have a background in some mathematical theories or something like that?
I'm not sure that you need a deeper background in mathematics, but I think that Haskell appeals to people to whom mathematics also appeals, right? That it's sort of it's attractive to a similar set of people. So it's not, I think, that you make any very direct use of mathematics, other than things that every programmer needs, like reasoning about, if I'm going to predict what this program is going to do, or think about its results, then I need to reason in a logical way. And there really is an answer. If I apply this function to this argument, I'm going to get that result. That is, you might call that computational thinking, but you might also call it mathematical thinking. But that's equally true if you're writing Java. I think it. Because Haskell functions, by default are pure, they behave like mathematical functions, so that the intuitions you get from maths when you say, if f is a function that squares its argument, or that when you talk about a function in mathematics, it's always implied that it's a function without side effects. Of course, you call it twice, it gives the same answer. Anything else would be stupid. So Haskell sort of cleaves to those same sets of intuitions, but I don't think you need any mathematical understanding to make sense of that. So no, and then you might wonder about category theory and functors and monads and so forth. Well, I didn't originally know any category theory, and even now, I'm a sort of weak category theory user, but probably I get most of my intuitions from programming with functors and monads rather than from the category theory itself. So I don't think you need to know category theory to write Haskell programs either. But I think probably more important than a sense about maths is, I think, the big thing that Haskell really pushes you towards is is taking types seriously. And I don't just mean as a little safety net to check that you don't add an int to a character. I mean that a type is like a weak theorem. It's a true statement about what that program does, and you can think of the function definition as the proof of the theorem, but the type is the theorem. And over time, you find yourself putting more and more stuff into the types. You want to make the in the olden days, do you remember the days of UML? Maybe you're too young to know about UML.
No, sadly, I had amazing experiences with
people said, what's the equivalent of UML for Haskell? And after a bit, I realized it's the types, right? We don't need a separate modeling language. The first thing you do when you start writing Haskell programs, you start writing type declarations for data types and types of functions. And that is a kind of design language or modeling language that enables you to think about the main pieces of your program and the data flows and what goes from here to there. And it's not just a modeling language that's separate. It becomes a statically checked, a machine checked part of your program in perpetuity. And that idea of involving more and more in types, that thinking I think really is pervasive and important to a Haskell programmer. It's much more apparent in Haskell than it is even in other statically typed programming languages. I'm not talking here about Scala or OCaml, which are in the same ballpark, but compared to C or Certainly any of these untyped languages, and that is quite a big cultural shift. And I think it probably does, again, appeal to mathematicians a bit more than to non-mathematicians. But anybody can accommodate it. You don't need maths. You don't need maths background to program in Haskell.
Right. You don't need maths, but you will be exposed to mathematical culture. For example, even in the GC source code, there is a lot of like variable names that are Greek letters. The rho types, sigma types, theta types, things that a person without mathematical background wouldn't pick as names for these variables.
Right.
Yeah, so nothing difficult, but you will get exposed to mathematical culture. I don't think it's a bad thing. It's like neutral.
Yeah, and if I may add some suggestions about what Simon and Vlad talked about just now, is a brilliant survey paper by Philip Wadler called "Propositions as Types." Is basically what Simon was talking about.
Yeah.
And another thing that that I like to throw at people who say that, oh, Haskell is bad for prototyping. First of all, what Simon just said, it's exactly perfect for prototyping, because you don't need any external tools to document your design. You just write some Haskell code, and you have your prototype, you have your proof of concept, quite literally. Yeah.
Yeah.
And if you want to read about that or even watch a talk about that, you can refer to Connell Elliott's denotational design. Tolkien, I think he has a paper on that, and it goes a little bit into maths also, but it's not too scary. I can promise, because I don't have any formal education whatsoever. All right, Simon, thank you very much for coming to talk to us. If you have any closing thoughts, please go ahead.
Let me just mention one thing. Is you mentioned that Vlad is full-time on Haskell due to Sir Okal, and Richard Eisenberg was also a giant, is essentially full-time on Haskell and both the foundation and the compiler. He works for Tweak. These are huge contributions. But I myself work for Microsoft Research, and Microsoft Research over 2 decades has been willing to pay me to spend quite a lot of my time working on Haskell and GHC. That too is a contribution from Microsoft that I am extremely grateful for and privileged by, and quite proud of Microsoft for doing it and continuing to do it. So thank you, Microsoft.
All right. Yes, it's very much appreciated, and we all appreciate your contributions personally as well.
Thanks.
Okay. Thank you, everyone, for coming in. Thank you, Simon, for taking time to talk to us. And let's keep
been a pleasure. And let's remember, Haskell and GHC in particular is everybody's. It's all of ours. That means that you should have a voice and you should contribute to it. It's a community effort, and the foundation sort of symbolizes that. I'm quite excited. That's one of the reasons I'm really so pleased about the foundation coming into being. Thanks very much.
Thank you.